Hello everyone and welcome to Vitush Academy. Today we will be diving into a journey through two powerful tools in mathematics for solving triangles, the Pythagorean Theorem and the Law of Cosines. By the end of this video, you'll not only understand the connection between these two, but also you'll see them in action with practical example where the cosine of 60 degrees simplifies our calculations. So let's get started, and first simply let's draw some triangle with 3, 4 and 5 here. 3, 4 and 5 would be the sides. So we have 3 and we have a 4, and here we have a right angle. So 3, 4, and somehow this one became 5 exactly. So this is for the right angle, and now the question is how exactly it became 3, 4 and 5, and why 3, 4 and 5. This would be 5 centimeters, and I think this was the 4, this was the 3. And why the 5 centimeters, the 3 centimeters, and the 4 centimeters together in a triangle? They always give a right angle triangle. That's a great question. So, and the answer is there is a theorem about it. So pretty much it says that c squared is equal to a squared plus b squared on the 90 degrees triangle. And in this case we will have c squared equals to 3 squared plus 4 squared. C squared is 9 plus 16. So C would be root of 9 plus 16. This is 25. So C would be 5. So this is pretty much the so-called Pythagorean theorem. And somehow, unfortunately, it only works when we have a 90-degree angle. And yes, this is not always the case with triangles. Sometimes we have other types of angles. For example, let's draw a triangle with 60 degrees. And by design, we would not be using the Pythagorean theorem because pretty much 60 degrees is, 60 degrees is not 90 degrees. So I just wrote this one, so it should be here, and 60 should be this one here. And just a second, okay, so yes, this is the 60 degrees. Yeah, let's draw 60 degrees triangle and see what we can do with it. Okay, this one is 60. Exactly. So what else should we do? Let's make this one 5. So up to here. And this one would be 4. So this is 5 centimeters, this is 4 centimeters, and our question would be how long is this one? Okay, we can calculate it. It's something like 4 something, doesn't matter, we will see it. So now the question for this one is how do we calculate this one? If we are not allowed to measure, we have the 60 degrees, we have 4 centimeters, we have 5 centimeters. Okay, so here the answer is we use this one with the law of the cosines. And the law of the cosines says we have c squared, which is this one, and this one will be c, and it is equal to a squared plus b squared. So far so good. Minus 2ab times cosinus C, cosinus, depending where you are. Okay, for this case here, cosinus of 90 degrees is 0, so 2ab minus cosinus c in this case is 0, so we say simply minus 0. Okay, so what's a cosinus of 60 degrees? This pretty much tells us how much is, if we're looking for the cosinus of this one, here we are taking a look of this CB divided by AB. So the maximum, it can be a 1, because this one can never be bigger than the hypotenuse. But in this case, the cosinus in our triangle here, CAB, for example, cosinus CAB, it would be 3. No, actually this is the sinus. This the cosine, yep. It should be, yeah, this one. 4/5, exactly. So 4/5 sounds great, but 4/5 is only pretty much the cosinus. But in order to get from the cosinus the size of the angle, we should take it the arc cosinus, or the inverse function, which is in general written as cosinus like this to the -1th. So this way we know it's inverse, and out of 4 divided by 5. Okay, so what is this equal to? Well, 4 divided by 5 is pretty much not -8, it's .8. And if you have some kind of a fancy calculator, you would see that the answer is .64. So it's .64, but it's in radians. And in degrees, this should be somewhere around 37 degrees. Yes, so this one is 37. And this one is 37, this one is 90. The third one is obviously something like 53, roughly. Okay, so this thing here with the sinus and the cosinus is really important in a way. So let's go back to our triangle here, where we have something like 5 centimeters here, 4 centimeters here, and the angle between them is 60. And we don't came up with this formula, it's just taken from somewhere. It's called the cosines formula. So what can we do with it? Well, pretty much we can solve it here, and we can say, yes, based on this cosines formula, we can take a look and we can calculate the C. So how do we do it? Cosinus of 60, pretty much. In the general case, if you can somehow imagine that this one here was, for example, not 53 but 60, what would have happened? Like if we increase this one, this here, and it was 60. Let's just imagine that this one was 50, not 53 but 60. Let's think about it. How can we do it? It should be somewhere here, and then like this, and our 90-degree angle would have been towards there. Yeah, just as an imaginable thing. Then in this case, we could have said that this one is not anymore 3, but it should be around 2.5, Can we say so? Well, with more fantasy, yes. So this should be 2.5 and this one should be 5. So it's obvious that this is where I'm trying to go. I'm trying to go somewhere saying that sinus of 60 is equal to 50% or 0.5 or 1 second. So let's write this down. I mean cosinus of 60, not sinus. Cosinus of 60 degrees equals half. Exactly. So we are saying to C2 equals A. A2 minus B2, doesn't matter which one is A or B, because in this case, yeah, we even don't have like right triangle angles, so treat everything equal. So it would be 5 squared plus 4 squared minus 2 times 5 times 4 times this thing here, and it's a 1/2. So C squared is equal to 25 plus 16. So far we are here. Almost. Minus these twos, they're going to be removed. Minus 20. So C is equal square of, I would say, square root of 21. So in this case, 21, okay, 4 times 4 is 16, 5 times 5 is 25. So C is equal something like 4 point, I'll go with 4.6. And it is 4.6 actually, yeah, roughly, but we are there. So we can always say that this one is 4.6. Let's measure it and see whether we are exact in our endeavors. Well, it's obviously more than 4, somewhere here, but it is 4.6. So yeah, we are okay so far. So let's connect a bit the dots. And what can we say is the following: whenever we have 90 degrees, then we say, okay, we are still using this one, but with 90 degrees, cosinus of 90 is 0. So we only use the first part, and this is where the Pythagorean theorem comes. But when we have like another angle, like for example, doesn't matter which one, we have the cosinus of all the angles in the world from 0 to 180 in degrees, then we can use this fancier formula here, and then we can go and calculate it, as in our case 4.6 centimeters. Okay, so now let's take a look at the programming part of the triangle, and so far just let's go there. And now let's try to replicate what we have done so far with pen and paper, but with Jupyter Notebook. So let's start importing math. Why do we need to import math? Pretty much this would help us to go from degrees to radians. So for example, if we do math radians and we say how many radians are 90 degrees, then the answer is 1.57. Well, something. How many radians are 180 degrees? This really looks like pi to me. Is it really pi? We can always compare, because this is Jupyter Notebook. Yeah, it is exactly math pi. Is this something that actually looks strange? I don't know, could be to you. If this is the first time you're seeing radians, then yes, 180 degrees are exactly math pi radians. And if you want to see how many degrees is 1 radian, this is what you do. 2 radians, this is how it looks. 3 radians, 3.14 is almost like 180, 1.5 or 1.6. Yeah, we are there. So it's 1.5 something. 152, I think. 1592. Okay, 1592. We'll have more. Yeah, so this is why we need to import math here. And now let's find a way how to calculate the third side. This is the function, and we need A, we need B, and we need angle in degrees. So what do we know? First, angle in radians, and this would be math.radians. Angle degrees, just tapping on top a few times. Okay, now c squared is A squared plus B squared minus. So far we have the Pythagorean theorem up to here, but this is not a 90 degrees triangle, so we do the fancy thing, minus 2 times A times B times math.cosines angle radians. Yeah, and this is c squared, and we're looking for c, so it should be return math sqrt c squared, and we can even make it a few better. We can return it like c, saying it looks like this, and here. Okay, so far so good. Let's try with a equals 5, b equals 4, and angle c would be 60 in degrees. And now calculate third side, should be a, b, as simple as that, and then angle c. Tada! 458. Yeah, this is from what I remember how much I was getting. I was getting 4.6 roughly. Let's see how much it is here. Print c squared. Yeah, it is 20, 21 obviously, and 21. I came with 4.6. I'm seeing right now, and here it is 458. So we are quite okay. I mean, we were quite okay when we calculated it with pen and paper. Okay, what can we do? We can make this one a bit more beautiful with more prints and information. For example, we can add a nice print with information here, a nice print with information after c squared. Tada! And something like this before return c. Tada! Is it really looking better? Probably no, but this way you would understand what's going on. And calculate third side. AB angle C. So convert angle 60 degrees to radians. It says how many radians it is. We need a full stop here because it looks nicer. Step 2, compute c squared using the formula. And the result is this one. Yeah, it's fair enough. Step 3, compute square root of c squared. C of 21, C because of this up to this fourth, and the answer is 4.5826. We can make it up to 1 digit. Let's see. Okay. 4. What about 3? Yeah, this is probably better. What about 2? Yeah, 4.6. This is the way it should be. And of course we return C as we are returning it because we can use it further. So far so good. Let's try to plot this triangle, and the question would be how. And now plotting the triangle, there is a separate function. Here, plot triangle fixed angle, pretty much. First thing is we do the angle into radians. We do the starting points. The A and B are somehow calculated. Yep. You see, like it's easy to calculate B once you have A, because it's obviously far away from B. This is how it is. So a triangle would be AB, like that, in a way. And then we have the C. Then we will be plotting the triangle. We'll be adding annotation to the vertices, and we'll be plotting everything. Let's take a look. I would say, and now what do? We do plot triangle fixed angle, and we use A, we use B, and we use angle C. This is how it looks like. We have side A, we have side B. You see, side B is 0 to the side A. This is how we get the B coordinate. Side A is 0, 0, talking about this thing here. And side C is a bit fancier. We're using B times cosinus of the angle of radians, and then B times sinus of the angle of radians. So far so good. And then at the end we also managed to get the next one. Yeah, so what should we think now? What can we do is we can fix A and B a bit. We can use the angle to be, let's say, 10 degrees. Yeah, and now this is how the whole thing would look like. It's really tiny angle. Sizes are the same, but everything is okay. We can even make it into 1 degree, then it should be almost a line. Yeah, and we can go with 90 degrees. And then we can go that this is the Pythagorean Theorem, which should be okay, I guess. Yeah, it is 90 degrees, you're seeing it yourself. And yeah, we can make it to 89, so you feel a bit unhappy if you are like with OCD or something, but this is how it looks like. So yeah, thank you for watching so far. Please let me know if you like this type of videos where I write on a piece of paper and then I try to replicate the whole thing with Python or not. So that's all from me. Take care and enjoy the rest of your day.